rolling. So good afternoon, everyone from the Chicago area, Hillside, Illinois, to be exact, about 12 miles west of the city, straight west of Lake Michigan in the center of this, not really the center of the city, but right where Buckingham Fountain meets Lakeshore Drive in Hillside, Illinois. If I stand up in my office, I can look down the expressway and see what I would call the Sears Tower, now the Willis Tower, the Hancock Tower, and many other high-rise buildings that have all kinds of fireproofing installed on them to protect them against fire and other issues. So, welcome to today's webinar, the NFCA webinar series. Today's program is on fireproofing inspection. My name is Bill McHugh, the Executive Director of the National Fireproofing Contractors Association. And joining me from Las Vegas today, Jason Anastasi from Rolling Plains Construction. He's actually helping us with redoing the inspection education program that we first wrote as NFCA in 2006 or 7. I retuned it in 2016, 17, and we're retuning it again for a 2022 version as well. Rich Walke is also joining us from consultant to the NFCA, Creative Technologies Inc. He's been a great resource for us for the last several years at NFCA, last 3 years to be exact. So just a quick couple of minutes on NFCA. We provide a lot of great things to the industry. We provide an annual conference called the Week of Learning. We've got education exams for the Contractor Accreditation Program and also for the UL Qualified Fireproofing Contractor Program. UL has agreed to accept that exam. The NFCA exam is a way to prove that a person has knowledge to become a DRI, Designated Responsible Individual. Once you're a DRI with the NFCA program, after becoming an accredited contractor, you can move on to becoming an accredited UL Qualified SFRM contractor. The website is where you find the fireproofing leaders. Our standards are there, the NFCA 1, 2, 3, and 400 standards that can be used for lots of different reasons. The NFCA is active in the code development process. We're currently at the final action, if you will. The public comment hearings take place in September in Louisville, Kentucky for the 2024 version of the International Building Code, International Existing Building Code, the administrative section, and as well as the other sections, structural sections, Chapter 15, Chapter 16 of the International Building Code. We're writing articles to get fireproofing out there in the world, and then we're at various conferences as well. We participate in lots of different things with the fireproofing industry, whether it's the National Building Code of Canada code development process, the ULC Standards Technical Panel, and the UL Standards Technical Panel for the ULC S101 and the UL 263. We're at ASTM, where we'll be at the E6 meetings in October. We were just at the National Association of State Fire Marshals conference in New Orleans a couple of weeks ago. We're working with the Canadian building officials as well. Big new deal, only a couple of years out, been published. It published actually June of 2020 during COVID. The National Fireproofing Contractors Association's Accepted Fireproofing Knowledge Handbook. It's a great book. For the specifiers, for the code officials, we give it away for free. For everyone else, contractors pay $195. Contractors, meaning the NFCA member contractors, NFCA member inspection agencies, and others. If you're not a member, it's a $500 upcharge, $695. We do lots of different things. Certainly, we have our webinars, but we also offer our education exams online too. I'll look for that to take place later this year. We'll be live again next year with our conference and also education for the exams. Also know that the NFCA's Contractor Accreditation Program offers a way for fireproofing contractors to separate themselves from others that just don't respect listings. That NFCA Contractor Accreditation Program is a great program to get involved with for contractors, and for the specifiers, specify it. It's a way that you know you've got a contractor company that understands the listings, understands the manufacturer's installation instructions. One step further is the UL Qualified SFRM Contractor Program. What's the difference? This one gets audited. In other words, the management system of the contractor gets audited by UL's staff to make sure that the contractor does what they say they do in their procedures all day long, everywhere, including the job site and the contractor's offices. So Rich Walke and I will be hanging out at the ICC for the code public comment hearing here in the next few weeks, about a month from now in Louisville, Kentucky. NFPA is just wrapping up their program. We had some of those discussions in early August, and then final hearings of that are in June of next year. The National Building Code of Canada development process for the 2025 version of the code still going on, and it's going to be going on for a while yet still. The NFCA has been involved with all kinds of different issues and codes. I'm not going to talk about them today because we've done it in our July program. Just a big thank you to this board of directors, our president, Carl Fernald, Rolling Plains, and then look at the rest of the people, as you can see. If you see them at an NFCA conference, thank them for their service. They'll be in Chicago for a board of directors meeting September 8 and 9. We'll look forward to getting together with them. If you're a member, thanks. If you're not a member, join the NFCA. Without your dues dollars, we can't do what we do with the codes, the standards development processes, whether UL, ASTM, or others. Without you, we can't do what we do. So info at nfca-online.org for an application. But today's program's on fireproofing special inspection. Where do we find special inspection? It's in Chapter 17 of the International Building Code. And it's not just about fireproofing, Chapter 17. There's probably 20 different things that get fireproofing special inspection. Special inspection is a concept where the building official absolves, not really absolves them, but assigns responsibility for inspection of a particular structural item to a third-party inspection agency that specializes in that type of inspection. And it's really an extension of the building department that is specified in Chapter 17 of the Building Code. The specifier then picks up on that special inspection, and then over in Division 1 of the specifications builds a schedule of special inspections, of which fireproofing is a part of. In Chapter 17, in the charging language, are requirements for the inspection agency, their qualifications, requirements for the special inspector, and what kind of qualifications they should have, that are very generic and apply to all the different disciplines that get special inspection, whether it's welding or other things. So let's get rolling and talk about fireproofing special inspection very quickly. And I'll let Rich talk a little bit about what gets special inspected, the two types of fireproofing, and what the standards are for that. But just know that there's two different sections of special inspection, one for spray fire-resistant materials, one for intumescent fire-resistant materials. In Chapter 17 of the Building Code, or Chapter 7 of the Building Code, you'll find key things, fire test standards, that define what fireproofing is. In other words, fire resistance rated assemblies and building elements, using ASTM E119 and UL 263 as a way to prove that the building element or assembly provides fire resistance. The fire test standards set up the acceptance criteria, if you will, and you'll hear a bit more about that from Rich here shortly. The point I want to make now as I roll through these slides pretty quickly is that there's several ways to determine fire resistance. First one's tested assemblies. Notice it's first in the charging language of the International Building Code. Second method, the analytical method, talks about determining fire resistance based on fire exposure and acceptance criteria in E119 and UL 263. Rich will talk about that later. And then there's a whole bunch of different ways to determine fire resistance in 70322. Approved sources. To me, that's a document such as the Gypsum Association manual and other manuals that are approved by the code official that have designs in them, tested and listed system designs. The prescriptive requirements and the calculations are all based on testing done decades ago. Remember, ASTM E119 UL 263 are about 100 years old. There was testing done many, many years ago that created some of the generic calculations and prescriptive requirements. in section 721 of the Building Code 722. Finally, engineering analysis based on E119 UL263. The final one points back to 70321, which is fire resistance designs by an approved agency, such as UL, Intertech, FM approvals, and others. Alternate methods are the final method, and this has got some things going on. We're not going to talk about this today, but just know that this 10411 section, alternative methods, just doesn't say, let's figure out how we can create fireproofing. What it does is says that the building code is first. If there's a tested and listed assembly, then that should be used first. And if there isn't one, then the alternative material design or method of construction can be approved. And in that section, it talks about fire resistance, 2.4, fire resistance. It's got to be equivalent in fire resistance. That means go back to E119 UL263 and compare whatever that rating is to what would be the acceptance criteria in E119 UL263. So at this point, I'll turn the slides over to Rich and let him talk a bit about the fire resistance, and then we'll hop over to Jason and talk about how to inspect fire resistance as well. So Rich, the floor is yours, and I'll turn off my camera and let you join the bus.
Okay, great. Thank you, Bill, and thanks for allowing me to join you here this afternoon. And good morning, good afternoon, and good evening to those of you who are in the audience. Thanks for joining us. My role here is to talk a little bit about how we establish fire resistance ratings. I've been saying for about 17 years now that in order to properly install fire resistive rated products and assemblies, you need to know a little bit about how these assemblies are tested in order to properly follow the listings and the manufacturer's instructions in order to comply with the published building code requirements. So that's my role here. So let's talk a little bit about then how these assemblies are tested and how these ratings are established. So there's really several standards here in North America that are used for establishing fire resistance ratings. Here in the US, we use ASTM E119 and UL263. Both those standards are referenced side by side in the various codes from ICC and NFPA. And I think it's safe to say for our discussion here, we can say those standards are similar, one and the same, and ultimately achieve the same test results regardless of which of the standards are used. In Canada, they use ULC S101. Likewise, I think it's safe to say that that standard is similar to the US-based standards, and we'd achieve comparable results with that standard as compared to the two US-based standards. So that's the good news. Makes life much easier. At one point in time, there was an NFPA standard 251 that's been withdrawn. It's no longer being supported. So for testing purposes then, the standard describes test procedures for the various components of a building. It describes a procedure for columns, for beams, for floor ceiling or roof ceiling assemblies, and for walls. So each of these assemblies are tested in accordance with that procedure described in the standard. And all fire resistance tests are conducted with the furnace temperature following the standard time temperature curve, which suggests we reach 1,000 degrees Fahrenheit in 5 minutes, 1,700 degrees Fahrenheit in 1 hour, and 2,000 degrees Fahrenheit in 4 hours. So that's the assumed temperature of the building fire. For testing purposes then, let's talk about each of these test procedures one by one, starting with the column, since that's by far the simplest process. The standard would suggest that the sample is a minimum 9 foot in height, so it's a freestanding column, and columns are typically tested unloaded here in North America. There is a test procedure for testing them loaded in the standard, but there are no labs that are capable of running that test, so they're all tested unloaded at this point in time. So here's a photo of a column that's protected with an intumescent fire resistant material. It's been slid into the furnace already and ready for the test. Ultimately, the fourth wall of that furnace then is slid closed, the gas piping system is hooked up, furnace fire is ignited, and then the temperature within the furnace follows that standard time temperature curve. And ultimately, the conditions of acceptance for a column is based on temperature. When the temperature of the structural steel reaches an average of 1,000 degrees Fahrenheit or 1,200 degrees Fahrenheit at any individual point, that is the temperature endpoint or the fire resistance rating of that assembly. The standard, again, does have a test procedure for testing these assemblies loaded. If the loading procedure were to be used, ultimately the criteria would simply be that the assembly needs to support the load for the rating period. Beams are tested in a similar way, only the samples are orientated horizontally. The standard would suggest our minimum length of sample is 12 foot, and that these assemblies are tested with an applied load. Basically, that load represents the maximum design capacity of that particular size structural steel or concrete or whatever the element may be. So here's a photo of a test sample that's been prepped. In this case, the sample represents a concrete floor assembly that's supported by steel beams. So the concrete has been poured at this point. Now the concrete would be put in, or assembly would be put into an elevated temperature curing cell where we drive off the moisture to a certain level in order to be able to run the fire test. Once that concrete's cured, the manufacturer comes in and installs a protection material to the structural steel elements of the assembly. Those thicknesses are determined by the manufacturer based on what they believe is necessary to achieve the ratings that they're trying to achieve. Here's a photo of the furnace that's used to establish those fire resistance ratings on the beams. Furnace is 14 foot by 17 foot by 6 foot deep rather. And after the fireproofing is cured, then the test assembly is placed on top of the furnace, and then the loading apparatus is placed on top of the test assembly so that we can load the assembly to its maximum design capacity. And that's a key point for establishing fire resistance ratings on horizontal assemblies. They need to be loaded to their maximum design capacity during that fire exposure test. You know, we occasionally see data run on smaller size samples without a load, and they're being purported as being tested to ASTM E119 or UL263, but in reality, that's not what the standard requires. The standard requires these assemblies to be loaded to their full design capacity and be of a certain minimal size requirement. So the conditions of acceptance for a beam would be the fact that the beam needs to support the load during the fire exposure period, and the average temperature of the structural steel shall not exceed 1100 degrees Fahrenheit, and no individual point shall exceed 1300 degrees Fahrenheit. So now let's talk about how we establish ratings on floor ceiling or roof ceiling assembly. So these are your overall floor or roof construction consisting of the structural elements and the, for example, steel deck, concrete, or whatever the assembly construction might be. Once again, we have a minimum sample size of 180 square foot with no dimension less than 12 foot. And once again, these assemblies need to be loaded to their maximum design capacity during the fire exposure test. And the process of building the assembly and testing is very much what I just showed you for the beam assembly, so I won't bother repeating that. But bottom line, the conditions of acceptance for the floor ceilings, roof ceilings, is the assembly needs to support the load for the rating period, need to prevent passage of flame from the fire side, or in other words, the underside of the assembly to the top side, and then they need to limit the temperature on the top side of the assembly to a temperature rise of 250 degrees Fahrenheit average or 325 degrees Fahrenheit at any individual point. And then the support structural elements need to meet those temperatures I just talked about for the beams. So at this point, then, I will turn the floor back over to Bill and let him talk about why we need special inspections for these products.
Yeah, appreciate that, Rich. Thank you. Appreciate you taking a couple of minutes to catch up on the key points about fire resistance in buildings, especially those horizontal assemblies. You made a good point about making sure that there's a load applied. When people are using that 10411 alternative methods, a lot of companies that have not done fire testing yet will say, well, let's just go under 10411. And there's a lot of little technical details in the fireproofing industry that might not show up on product data sheets, like was the horizontal assembly tested with a load to it. So really appreciate that. Very quickly, before we move on to some of that, let's take a look at what the Chapter 7 of the Building Code says when it comes to installation of fireproofing. It's going to want a listing. out of the UL Product IQ or other directory. So we're going to go look for whatever assembly it is, whether it's PPG or GCPs, Monocoat, whatever it is. There's going to be a listing of some kind out of Product IQ that's going to tell us what the type of material is and how it's installed, or at least what the type of material and what the thickness was for the fire resistance rating. Then we're going to go to any of the manufacturer's websites and grab the product data sheets. Why? Because the building code says install in accordance with the listing and the manufacturer's installation instructions, whether it's AD, GCP's Monocoat, CAFCO's, the Isolitech CAFCO materials. Regardless which material it is, Hilti, PPG, Sherwin-Williams, or Albiclad, whatever the product is, we're going to go look for that product data sheet, because on the product data sheet, it's also going to talk about installation instructions, and there might even be an extra installation instructions, because the installation instruction is not defined in the building code. Therefore, we have to go to the Consumer Product Safety Council, or Consumer Product Council, if you will, and it's going to talk about that installation instructions would mean anything needed to install that product correctly. To me, that's a product data sheet, safety data sheet, and installation instructions from the manufacturers, all three of those pieces in order to make that work. So moving forward, a couple of things to remember. IFRM is now one term in the 2024 International Building Code. We've changed that from mastic fire resistance coatings to intumescent fire resistant materials. And we've made spray fire resistant materials fire resistive in the International Building Code. We'll be working at NFPA to do the same thing. You find fire resistance in high-rise buildings. We talked about occupiable roofs in our last program. Know that special inspection for fireproofing is as a continuous process as the building is going up, if you will. And it gets a separate second inspection as well. The approved agency that does the special inspection has to be approved by the building official. So that means the company has to be approved. And then the inspectors have to be approved as well. And that special inspector is a qualified person that has competency. Notice that the building code doesn't ask for a certified person. It asks for a person that has proven competency. How do they do that? A certification might be a way to prove that. Another way would be passing an exam and providing a resume of experience that the inspector has. The agency has to be independent, and so does the special inspector. The agency has to have equipment to do the inspection and personnel that know what they're doing. The special inspections are done by the owner or the owner's authorized agent other than the contractor. As far as special inspectors, here's the competency that's required, and we'll just kind of leave it at this. Know that the building code asks for experience or training, has to be relevant, and the training's got to be related in complexity to the same type of special inspection or testing for similar complexity and material quantity. So the reason I do this is just so that you know, as a contractor, if you've got an inspector that has no idea what they're looking at, the building code is quite clear that the inspectors that are doing this work have to have specific qualifications. You may want to complain if that inspector doesn't have the appropriate qualifications. You may not, for fear of retaliation, if you will. But building departments know that when special inspection is done, that the building code is screaming at you to do the appropriate qualification of the inspection agency and then also of the inspector. ISAC 291 is a way to get that done as well. Other key things to remember: the reports in the inspection section of Chapter 17, if there's deviations to the tested and listed system or the installation instructions, they've got to be reported immediately to the contractor. That's a pretty big burden on the inspection agency. But with today's technology, email, text, WhatsApp, cell phones, this can take place pretty quickly. Suggest that a pre-construction meeting take place to determine what the definition is of immediate as well. So let's get one other thing out. This is in the 2021 version of the International Building Code. The 2018 version basically said that this inspection takes place after everything's done. And that's not the way fireproofing inspection has taken place over the last decades, several decades actually. So the NFCA put in that the building, the special inspection take place in the building during construction, and then there'll be an additional visual inspection after the rough installation of mechanical, electrical, plumbing, and then the ceiling grid and all that kind of stuff. Why? Because that's the way fireproofing gets inspected. Same thing exists in the intumescent fire-resistant materials section as well. And again, the 2024 version will change the name to spray fire-resistant materials from intumescent. And at this point, I'm just going to zip through slides quickly so we can get to the physical tests that are that take place for fireproofing that Jason's going to cover as well. But here's what the building code says. In one comment, you know, the Chapter 17 of the building code for fireproofing is quite extensive. It's a big, long section of Chapter 17. And for a good reason. The Ad Hoc Committee on Terrorism-Resistant Buildings that was appointed by the ICC Board of Directors in about 2003-04 after the World Trade Center collapses, the attacks from 9/11, if you will. That Ad Hoc Committee looked at fireproofing very closely. Bill Connolly from the state of New Jersey drove the bus on it early on, and then Gary Lewis from Summit, New Jersey chaired it. I sat on that committee in the second go around to get several code changes in to address problems that the National Institute of Standards and Technology found through their study of the World Trade Center attacks. If you ever get a chance, go take a look at those documents. They're publicly available. Just search the World Wide Web and put in National Institute of Standards and Technology NIST report on the World Trade Centers. 1, 2, and then also 7 had great reports, 1,000 pages, but there's an executive summary that's about 100 pages. What do we look at? Condition of substrates, thickness of application, bond strength, huge change that took place from the 9/11 Ad Hoc Committee on Terrorism-Resistant Buildings, density, condition of finished application are all important things to look at. Take a look what's in Chapter 17. It references the listing, the tested and listed fire resistance design, and the written instructions of the approved manufacturers. Surfaces got to be free of oil, other crazy things that would impair the adhesion of SFRM. The application has to be done at certain temperatures. This is all in the special inspection section. This is almost reading like the manufacturer's installation instructions, but it's there for a good reason to make sure that the building stays standing when the fireproofing is exposed to fire in some kind of a condition. Know that the bond strengths vary based on the height of the building. You know, once you get up above that 420 feet above occupied floor, 420 feet above lowest fire department access, then you're getting in the super high-rise category where the 1,000 pound per square foot bond strength is required. E736 is what's referenced. The frequency of sampling, I'm not going to get into the words. I'm going to let Jason jump into that here shortly. No bond tests have to take place if there's a primer involved, and we're not going to get into the specifics of it. So let's see where we are now. Just know that you know, the bays have to be inspected, because that's what it says as far as the frequency of inspections. Know that thicknesses have to be checked. Know that a column is a column and a beam is a beam. The primary beams, the structurals, the secondary beams, if they're required. The thicknesses have to be measured. And again, there's a frequency for this as well. Not more than 10% of the thicknesses shall be less than the thickness required by the approved fire resistance design, and none shall be less than the minimum allowable thickness in 1705-1541, and that's where it's going to start talking about ASTM E605. That document gets discussed at the E6 meetings, which will take place in October down in New Orleans. That standard has not had many changes to it in the last several code change or standards development cycles. But just know there's some variances that are in here, but it's all sitting in E605, and that's really the Bible when it comes to measuring the minimum allowable thickness for fireproofing in new construction and, if needed, in existing buildings as well. Know that beams have thickness taken at 9 different locations. And then there's a formula for acceptance of that as well. I'm not going to go into the details because we have about an hour for this and not 2.5 to 6 hours. But just know that the thickness gets measured, full design thickness, measured at locations 1, 2, 3, 5, 7, 8, 9. Half of the full thickness at, or minimum 1/4 inch at 4 and 6. So what's 4 and 6? That's the flanges. That's the hard place to get fireproofing at, spraying that type of an assembly as well. And then it talks about repeating the above measurements at a location on the beam 12 inches from the first measurement set, and then off you go. When it comes to thicknesses on floor, roof, and wall assemblies, E605 talks about it as well. Not less than 4 measurements for each 1,000 square feet, 993 square meters in each story. Cellular decks have, again, not fewer than 4 measurements again. And let's talk about fluted decks. Here you go. Same thing, not fewer than 4 measurements symmetrically. Then it'll talk about how to measure that under E605. Structural members, such as plates, here you go, 12 by 12 locations. And at this point, I'm going to back up to 70 and let Jason hop in and start driving the bus about measuring thickness of fireproofing. So Jason, if you could hop on, turn your microphone on, and turn your camera on. I need you to get to full screen mode there, and then you can drive the bus there as well. So Jason Anastasies comes from a really cool background, both special inspection and contracting. So let's let Jason drive the bus through some of the details here about measuring thicknesses for SFRM fireproofing, and we'll get into IFRM fireproofing as well. If we run short of time and don't get to the IFRM, we'll just make that another webinar in the future. So Jason, I'll turn off my camera and let you drive the bus.
All right, well, good morning, good afternoon, good evening from sunny Las Vegas. Thank you for allowing me to attend and contribute to this webinar. I've been dealing with inspection inspectors for the last 10 plus years, and my role for today is to explain some of the fireproofing SFRM testing that occurs. I might drop a few horror stories about inspectors along the way. Before I start, here's a question for the audience. How many of you have inspector horror stories? I'm going to bet that quite a few of you do. So our understanding of the testing requirements, put forth by ICC UL, it help us successfully navigate these issues. That's what we're going to get into today. Won't talk too much detail about these because, as Bill stated earlier, these are getting updated, and we'll hopefully have that out here in short order. So 1705.15.4.4 talks about fluted decks and how to perform the inspections on that. Essentially, let me get rid of this here. Apologize. There we go. Apologize. So essentially, you're going to select a square area 12 by 12 in size and gather 4 measurements from each side symmetrically within the square area. So it's going to be the valley, the crest, and the sides for a fluted deck. And the average of those measurements shall be reported. So I think okay. Did that skip? Okay, apologize. There's a slide for that. So this talks about thickness of structural members. Again, we're going to reference ASTM E605. The ASTM is the actual test method on how the procedure is done, how the test is done. And it shall not be performed on less than 25% of the structural members on each floor. So if you have a flat deck, I haven't seen too much of that in my career, but you would essentially take, again, a 12 by 12 template, and you would follow the diagram there and gather those 12 measurements. And here is a flat deck. And then there is the bottom of the flute, the flat portion of the deck, the side of the flute, and that's where you gather those measurements. So 2 sets of thickness measurements are required on each beam, joist, and column. When finished making the first set of thicknesses measurements, move 12 inches away on the same structural element and make a second complete set of measurements. Now, I've had inspectors in the past grab 12, one set at 12 inches and then move to the other end of the member and take another set of 12. And I always ask them, where is that in the code? Where does it say to do that? And they can rarely ever, they've actually never been able to show me in code where it says to move the other end of the member. So on a column, okay, I didn't realize that was going to have an audio file there. So location for measuring columns, you're going to take 12 measurements around a column, and it's important that you always start in the same place. So whether it's, as the diagram shows here, on the flange tip for number 1, or you start on the inside flange where number 2 is, always start in the same place. So when you look at your reports and you find your inspector's reports, and he says that you've got a low spot on 5 and 7, well, on this diagram, you know that it's the flange tips. If you start on the inside web, then that's going to be number 4 and 6. It's always important to note that so you know where your low spots are. And you can go back out and verify and make sure the inspector wasn't hunting for a low spot. And again, you're going to move 12 inches in either direction. Hey, Bill.
Gotcha.
Hey, is it doing subtitles or is it reading off to you as well?
No, we can't hear anything there. So.
Oh my gosh. Okay, I'm sitting here like, what is going on? I apologize. So
Yeah,
I'll just talk over it. So recorded results and averaging column data. Full design thickness shall measure the 2, 3, 4, 6, 8, 9, 10. And again, that is based on these locations here. 2, 3, 4, 5, 2, 3, 4, 6, 8, 9, 10, and 12. So 1/2 full thickness for a 1/4 inch measurement at 1, 5, 7, and 11. And you repeat the above measurements at location of the column 12 inches from the first measurement set. So thicknesses on beams and girders. At beams and girders, thickness measurements shall be made at 9 locations around the beam or girder at each end of a 12-inch length. So again, that's per ICC Chapter 17, and it's also listed in the ASTM E605. So this is where you check your measurements on a beam. You've got 9 measurements. You move a foot down, check another 9. A lot of times I'll see inspectors trying to take measurements from the top flange where it meets the deck. And that, as you see, is not an inspection point. They will always try. This is the 12-inch measurement separation between the distances. It's good to measure that out and have an idea of where you're going to be testing. Thicknesses around joists and trusses. Joists and trusses, 7 locations around the joist or truss at each end of a 12-inch length. And I think there's a diagram for that. There is. So you've got the top chord, you've got the middle diagonal, the bottom chord, the bottom of the bottom chord, and then around and you're going to run another 12 inches on down that side. So recording results and averaging joist data. Full design thickness shall be measured at locations 1, 2, 3, 4, 5, 6, 7. So you're going to do them all, move 12 inches down, and you're going to calculate the full thickness on those locations. And for wide flange columns, so that's your eye-shaped wide flange columns. At wide flange columns, thickness measurements shall be made at 12 locations around the column at each end of a 12-inch length. And I've seen also inspectors where they're trying to gather 6 or 7 measurements on a flange tip, like looking for a low spot, and they can't cherry pick the areas. And I think we're going to come to that here shortly. For HSS, hollow structural sections and pipe columns, so whether it's a rectangle, a square, or a round tube, you're going to grab 4 measurements. It says not 4, not fewer than 4 locations around the column at each end of a 12-inch length. Sometimes I've seen inspectors try to grab a inspection point on the corner of the HSS square tube. And again, that's, you know, not listed. Density selection and testing. So dry density, the density of this SFRM shall be not less than density specified in the approved fire resistant design. So again, it's an ASTM A605, and we're going to grab a sample not less than 1 for every 2,500 square feet or portion thereof sprayed in each story. This has been an update since, I want to say 2009. Bill can correct me on that. But it's definitely increased, and it's becoming a thing out there. So there's a column web, column flange, beam web, bottom beam flange. Just for simplicity, we like to grab them from the webs if possible, or the web of the beam, or the column flange face. That's just for you know, ease of access, and also if you're doing the patching of the material or the fireproofing, it just makes it easier to visually see it. The deck density sample shall be selected from the flat portion of the deck profile. So that'll be basically on the bottom end of the flute there. So this, what they're showing here is the thickness method for dry density testing. And it is the, I would say, the older method. It's still in use by a lot of inspection companies. We highly recommend the bead displacement or volumetric method for dry density testing. It's more accurate, and we'll come to that. So as you can see here, he's ripping off samples. And on this particular test, you have to gather every ounce, every gram of material. If you don't, you're going to have issues. Prior to doing this on the thickness method, he would take 12 measurements across the face of that thickness, or across the face of that fireproofing in his sample size. And he would take those 12 measurements, record those averages, and then cut this out and remove every bit of fireproofing and capture it in a bag. I can tell you right now that rarely happens. There's always, you know, flakes and stuff that fall off, and people, I don't get it. Or you'll find an inspector who will take just a little bit more just to make sure he has enough. So this is a sample selection for it. Each protected element, 2,500 square feet, area of each floor, roof and wall assembly, structural member in each story. So what are we testing? It's a deck flat portion, the beam lower flange, or column, either flange or web. So here's the volume displacement method, or the volumetric, or the bead displacement. It's the most accurate. It measures a regular size sample secured from protected element. This is what we prefer. We, you know, how during our pre-cons, we'll ask the special inspector, you know, what test do they use? Most of the time they won't be able to tell you off the top of their head. But when they do come back, it'll usually be the thickness method. That's just because it's been around. With this, you know, we encourage them to take a look at the ASTM E605 and read the section on bead displacement and or the volume displacement method, and get them schooled on that. It's very important that we don't overcook the material. So here we are drying out the material. So there's two ways to do it. One is room temperature or atmospheric, and the other is forced cure in an oven. So your temperature must not exceed 109 degrees plus or minus 10 degrees Fahrenheit, or per the manufacturer's requirements. So, 99 to 119 degrees Fahrenheit is where you want to keep your temperature of your oven when you're curing the samples out. You also want to grab temperatures readings every 8 hours until you get to a constant weight. So here you're taking a larger sample, the 12 by 12, let's sample, say that they took, and they're cutting a smaller size to run in the bead displacement. First step, weigh the sample. Then you pour your beads into a container, smooth it off or screed it off. You place beads into another empty container, pour those beads out of the tray because you're not going to need them. Okay, so now we're actually going to start the actual test of this. So you know the known volume of the container that's in his hand right now because you've already filled that container. You're going to pour beads back into this container, leave about 1/4 inch of material on the, or 1/4 inch of beads on the bottom and 1/4 inch space around the sides. You're going to place your sample inside the cylinder, and then you can actually gently just put that in there. You don't have to like press it down or do anything. Then you basically take your funnel and you pour your beads around the sample. And then you have, once you pour all those beads in, you're going to screed off the top. Then you're going to have your leftover beads or your displaced beads in this pan here. You take those beads, pour them into another container, then you pour them into a graduated cylinder to determine the volume. And I believe this is a 250 milliliter graduated cylinder. You read it, and please read it like he is by holding it up in the air. Don't lay it down on the ground or on a desk. That way you get an accurate number. And then you record the sample volume and the oven dry weight. And then here's your formula for that. So you take your dry weight of the material times 62.43 divided by the volume or the displaced volume, and that will equal your dry density weight, your pounds per cubic foot. It's much more accurate than the thickness averaging method that was used back when I started doing this. Bond strength. Bond strength is always, it's becoming more and more prevalent on projects. I mean, with standard density, standard density has always been there, but it's becoming more and more common. I've seen on medium density and high density products now. So for bond strength in the IBC chapter 1705.15.6, so the cohesive adhesive bond strength of the cured SFRM applied to floor, roof, and wall assemblies and structural members shall not be less than 150 pounds per square foot. The cohesive bond strength shall be determined in accordance with ASTM E736 by testing end-place samples of the SFR material selected in accordance with 1705.15.61 through 63. For floor, roof, and wall assemblies, again, this follows the bead displacement or the dry density testing. It's one sample for every 2,500 square feet of the sprayed area in each story. For structural members, it is going to be the same, not less than one sample for each type of structural member for each 2,500 square feet. So, structural member, so primary, secondary, column, if your diagonals, whatever, that's going to be one for each type. See if I can, there we go. So primers, paints, and encapsulants. So bond test to qualify a primer, paint, or encapsulant shall be conducted with a spray applied fibrous material applied to a prime, paint, or encapsulated surface for which acceptable bond strength performance between these coatings and the SFRM has not been determined. So typically we'll reach out to the manufacturer, the SFRM manufacturer, find out if the primer or paint has been approved. If it has, we're okay. If it hasn't been approved, this is where this comes into place. Or if you don't know what the primer is, and that happens on projects as well. So a bonding agent approved by the SFRM shall be applied to a prime, painted, or encapsulated surface where the bond strengths are found to be less than required values. So that'll be your bond seal or fire bond, those type of things. Bond strength testing. All too often I've seen inspectors do this exact test right here and not keep the scale perpendicular to the floor. They off at an angle, they're worried about the cap flying back and hitting them in the face, which can happen. But it's absolutely imperative that you pull slow and steady. I want to say the code says it's like 11 pounds per minute or something like that. But you want to keep that scale completely perpendicular to the floor. You don't want to tilt it any which way because you'll create shear and that'll invalidate your test. So measuring medium density SFRM. So this is an older style, at least it's an older style to me. Thickness probe, it's got a thin probe on there. Most of the ones I've seen these days have a thicker probe, it's a thicker needle, which definitely helps with medium density and high density. On these thin probes here, you'll see that they have, that they'll bend. So it's important that we get the thicker probes. And essentially what you're gonna do, let's see if it shows it here. Basically place the flat end on there and then slide the needle into the material. You don't want to compress the disc onto the SFRM. It's meant to be irregular, so that's what the disc is for. It's a 1-inch disc on that. So taking your thickness measurements, like I just said, flange tips. Flange tips are typically a little harder to find unless you're shooting like a 14 by 370 or 14 by 550 column, something like that. If you're doing a 12 by 14, your flange tips are considerably harder to find, but just kind of probe around there carefully and you'll find it. So for high density SFRM, I've used drills like is pictured here. I've used a hammer and nail. The material, as you all probably all aware, it's like concrete, Portland cement base. So it's hard to get through. Your needle, typically the probe typically won't slide in all the way to the substrate easily. And that brings me to something else. I've also had inspectors tell me on a high density product that I'm not at thickness. I'll go measure it and I'm at thickness or just above, and they're telling me they're a half-inch low or whatever the case is, and that's because they're not getting all the way to substrate. They're not getting to the steel. And that's typically where that problem is. So you'll insert the probe into your drilled hole or with the nail, and then repair it. So measuring high density SFRM thickness, bond strength for medium density, bond strength testing, flat surfaces. Okay. So with bond strength testing on your low density or standard density materials, you'll use, it talks about a 2-component urethane epoxy or adhesive or a suitable adhesive. I've had great success using a product called Great Stuff. It works well, no issues with it, and it adheres well. So for medium density and high density products, you need something that's actually going to adhere very well. So you'll have a 2-component urethane epoxy or an adhesive like this, or for high density, you'll need an epoxy called 2-ton epoxy. Definitely wear gloves, it gets messy. And 2 3/4 inch inside diameter jar caps, lids, those I want to say now you're able to get 1 7/8, 2-inch and 2 1/4 inch lids for various manufacturers for the different SFRMs out there, and that will reduce the amount of pounds you have to pull. So with a 2 3/4 inch cap, for instance, or even the old 3 1/4 inch caps, you would have to pull, 50 pounds on a scale to get to, 1200 PSF. So the smaller the diameter of the cap, the less you will actually have to pull. I want to say for standard density, it's somewhere around 8 pounds to get to the 150 range. So that definitely helps. And then you would take a screw eye here, you would screw it into your lid on the previous page. I typically use eye bolts with a nut on the end of it so it doesn't pop out, because sometimes that screw will come out at you. And then there's a 100-pound capacity spring scale. I found that typically a 50-pound scale is sufficient. And then use your awl to pop the hole in the lid for your screw. And so this is what they're doing here, putting that hole in there, putting the screw in. Select the location for bond test. You want to select an area that's representative of the area. You would prefer to do it on a flat surface like this. I've also seen inspectors in the past where they will take a 5-in-1 or some type of a spatula and scrape off the surface to make it flat, and you're invalidating the test, in my opinion, because that's not the system that's in place. So here they're mixing the urethane, part A, part B. When you do use this, make sure that your ratios are correct, 1-to-1, or however the manufacturer says to mix it. They have a lot of times you put too much A or too much B in, and you'll just end up with a gooey mess that doesn't really do what you need it to do. So you pour it in there, mix it well, make sure it's the same color. Place cap on the SFRM. Instead of sitting here and holding it for 15 minutes while it cures, I'll typically put two screws on either side with a rubber band stretching from screw to screw, and that holds it in place while the adhesive cures and allows you to allows you to do the pull test the following day. So yeah, you can sit there and hold it for 15 minutes. And then the next day or the later day when you come back to your test, remove the excess material that eased out beyond it. And then from there, sorry, excuse me one second. Do not cut into the fireproofing around the cap. And then you attach your spring scale and then pull consistent, slow, and again, remain perpendicular to the floor. So continue to apply tension until failure occurs or the scale reaches capacity. As you can see in the picture on the right, it can be violent. Record the maximum load. And then there's your formula for the bond strength. High bond strength, this is a complicated test. And Bill, I don't know if we're running out of time here, but this one, it's a dangerous test. You're dealing with a lot of energy if this were to pop off. So essentially, you're going to get a 1.3" wooden diameter, a disc, and what I've used in the past for this is a 1.5" curtain rod, which is actually 1 3/8. You put your eye bolt in there. You take your 2-component epoxy adhesive with 4,000 psi, so 2-ton epoxy. And then you get your 1,000-pound portable load cell. And there's one that I've used in the past. It's called a James Bond tester, and it is it's quite the machine. And then you need a drill, a 4-star bit, and that's basically a wood drill bit. And then you take a level, and you will level out the wooden disc, make sure it's level, because you want this to be perpendicular. You don't want any shear on this. This is the biggest issue that comes with this test here. SFRM shall be applied to a substrate in a thickness not less than 3/4 inch. This procedure shall not be used for a thickness application less than 3/4 inch. So, how do you do a high bond strength, or how do you do a test on a high density product with 3/8 inch thickness? Well, per this, you shall not do this test, right? You allow the material to set. and material containing cement shall be cured for a minimum of 28 days. That's also another thing because a lot of these jobs are fast tracked. So use the bit, drill a hole to a 1/2 inch from the surface, no less than a 1/4 inch deep. Remove any loose dust or any loose material. So I typically take a can of compressed air, blow it out, mix the epoxy, you get it on the wooden disc. I would already at this point have the S-hook applied to the eye bolt, and I would place it in there, and then I will let that epoxy cure out, whatever it says on the box, and then apply at a low rate of 50 pounds per minute, and record the peak low from the load cell in pounds. And again, that's the James Bond tester does that really well. So again, you've got the formula here, which is the cohesive bond strength of high densities. All right, Bill.
We'll wrap it up there. Well done.
All right.
Let me take the slides back. Inspection of fireproofing, and feel free to leave your camera on there, Jason and Rich, because we got a couple questions coming up here. But as you can see, fireproofing is manufactured, SFRM fireproofing is manufactured in the field. It's not something that's made in the factory. So what the building code is doing is bringing forward procedures to do quality control, basically, if you think about it, in the field to make sure it's mixed right, make sure it's strong enough bond strength is the big thing. There was, at the Terrorism Resistant Building Committee, that was probably a 6-month discussion about should the regulation be about bond strength, density, or what. And the conclusion was bond strength was the most important piece to keep an eye on. So know that we will be doing future webinars on inspecting IFRM and also boards and wraps. Why would I mention boards? Gypsum board has some assemblies in the UL directory, in the gypsum manual. And there's also mineral wool board that gets installed as well. But what I wanted to do is point out in the building code that there's a section on the special inspection area where structural observations are. I'm trying to think, I just had it, here it is. So, where it talks about general in 1705.1, that covers everything that's listed inside this section. But boards and wraps, as well as, the boards used, gypsum boards, all that kind of stuff, doesn't really have a section on special inspection. But special cases are mentioned inside the charging language that talk about, special inspection and tests for proposed work that's in the opinion of the building official, unusual in nature, but also alternatives, they get special inspected as well. And there's also some other sections in here that will talk about that too. But let me get down to another section that talks about when special inspection takes place. I made the point earlier, but it really needs to be made again, and I'm going to do it through the building code under sorry about scrolling quickly, but in the fireproofing section of special inspections, if you will. And at the charging language, I'm looking at the 2021 version of the building code. So let's blow this up a little bit and show you what the NFCA did in the last code development cycle to fix something that was in the building code that was incorrect in our opinion. The way fireproofing works is the special inspection is performed during construction. That's when the special inspection takes place. And then after the mechanical, electrical, plumbing people come through and knock off any of the fireproofing to weld things and attachments to their fireproofing, it gets touched. And to make sure that it's been fireproofed again, the additional inspection takes place, additional visual inspection, after the rough installation of all the rest of this stuff. Key point to know. So let's get to the questions real quick at the end of our program here. A couple of them have come up. Sorry about that. I moved something to the wrong spot. Let me move it over here so I can see it again. First question that came up is on primers. Is galvanization considered a primer or an encapsulant? That might be a question for Rich. Rich, any thoughts on galvanizing? Oh, you're muted there.
Yeah, I believe galvanizing is treated as an unknown primer. So the rules for dimensions and bond strength and so on that apply to unknown primers also apply to galvanized steel.
Cool. Let's see. Next question came up is if a product is cement-based, Portland cement-based, is it required to be room temperature dry during the testing? The density is lost if the cement gets cooked, as the person says. Jason, Rich, any thoughts on that?
In terms of the drying during the testing process, UL is very careful not to reach that point where we're driving out the moisture from the cement or gypsum or whatever the fireproofing is constructed of. So that is definitely kept in mind. So it does not get, quote, baked during that process. There is an accelerated curing that UL uses. It's about 115 degrees Fahrenheit and about 15% relative humidity, sort of like Las Vegas in the summertime, Jason. But that shouldn't have an impact on baking out the moisture.
Fair enough. Next question, Jason. Any thoughts on that? I saw you shaking your head. Yeah. Any
no, I agree. It's such a low temperature that it's doesn't really affect that from what I've been told by the manufacturers.
Fair enough. Next question is, what section of the building code covers the points of inspection on the structural members? The building chapter 17 doesn't seem to contain the diagrams that we put in there or the calculation formula.
So those have been typically found in the AWCI 12A manual, 12B manuals. It's where those diagrams live.
Yeah, and the recipe comes out of the ASTM E605 for measuring the thickness. So that's the governing document really that's referred to in the building code. So the diagrams aren't in the building code. I don't think it's in the commentary either. When I looked at it, I didn't see it. Let's see, next question. It seemed like thickness inspection procedure described half flange design. Is there a difference between full flange design inspection and half flange design inspection?
So the inspection is this. Oh, go ahead, Rich. I'm sorry.
It says, would the half flange design tips only need to measure 1/4 of the thickness requirement? Is the question. Go ahead.
So the inspection is performed the same. You still gather on whether it's a column or beam, you're going to gather the 12 measurements. The only difference is when it comes to the thickness averaging is where that changes.
Okay. Let's see. So the galvanized considered a primer or encapsulant. Does it need a bonding agent applied prior to the spray applied fireproofing?
Yes, it does. And refer to the manufacturer's guidelines. What they whether it's GCP or Solitech, they'll tell you if it needs to have, and I believe that it's always the case. Absolutely.
Cool stuff. Okay, so looking. Another question came in, can the sprinkler system inside the building waive the fire rating? Good question. It's funny, I was at the National Association of State Fire Marshals conference 2 weeks ago down in New Orleans, and I saw a presentation about substitutions such as that. Let me take you to a section of the building code that addresses it loud and clear, actually, in our opinion. Let's get to 2021 building code, pulling it up. Let's go to chapter 7 at the charging language 703. And there's a section in 703 that talks about not having sprinklers spraying onto the assembly, assuming that it's, let's see, where is that one? Here it is. Let's see, which one is that? Forgot where that is, Rich. What am I thinking? 703.
Yeah, it's 703.3. So move down a little further.
Yeah, okay.
There we go.
Go further up.
Yeah, let's see.
It moved from the 2018.
Moving so fast, I can't focus my eyes to tell you exactly where it
Sorry
is.
about that.
Okay, let's see.
I think it's back
Tell
here.
you what, I've got my IDC open. I can get to that a lot easier and tell you the section number.
So in 21, they moved some things in the 21 code. And let's see. And basically what it says is that the fire resistance is not to be determined with spraying water on it. So there are, going over to other places in the code where there's something called a sprinkler trade-off, where you add a sprinkler, you move some fire resistance from a building. That's over in table 601 of the International Building Code. But what we wanted to point out was another section. I apologize for making you dizzy as I scroll through this.
It's 703.2, fire resistance. It says the fire resistance rating of building elements, components, or assemblies shall be determined in accordance with 703.1 or .2 without the use of automatic sprinklers or any other fire suppression system being incorporated, or in accordance with 703.2.
So it's up in the charging language is where they moved it to. That used to be another section further down. But really the question is, fire resistance, in our opinion, is primary. If you think about it, there was another study done that was published recently where it talked about the reliability. It's actually in the NFPA's economics report that's not published yet, but as I was reading through it, it talked about the reliability of fire in buildings, fire spread in buildings, and fire protection in buildings, and talked about fire resistance being there, and then the effectiveness being like 92%, and then add a sprinkler and it goes to like 96%. So my question always is, which one provides safety? My opinion is all of the above. The sprinkler, the fire resistance, the alarm and detection system, and the occupant education to get people to figure out what to do when the fire takes place. So let's take a look here. There's a couple more questions that came in. If the flange tips only need to measure half the thickness requirement, why are there half flange designs? Any thoughts on that question?
Yeah, I'll jump in if Jason doesn't have a response. Basically, it's because it's difficult to spray the material and get it to stick onto the flange tips. And so typically, in the early days, manufacturers all try to have a uniform thickness around the entire beam or column. That proved difficult to do. The flange tips were always seemed to be light, so therefore, manufacturers came up with this concept of half flange tip thicknesses, where the requirement for thickness on the tips of the flanges was half of that on the rest of the beam. Ultimately, what that required is for them to, I'm going to say, overspray or apply more material on the rest of the column or beam to offset that half flange thickness on the tips of the flanges.
Fair enough.
So it's more of a convenience factor, I think, than anything, or practicality of doing the application.
And they passed the fire test that.
Absolutely, yes.
Yeah, absolutely. Cool. Okay, looking at the chat, not seeing anything else come through. Aha, another question popped in. Can you share the reference when the deck should need to apply SFRM or IFRM? What are the minimum thicknesses of concrete casting over the decking would be the question. That's an easy one. So in other words, go ahead, Rich. Looks like you're getting started.
Yeah, I was just going to say that ultimately the need to provide fireproofing on the bottom of the deck and the thickness required, thickness of concrete, all of those factors fall out of the individual fire resistive designs.
Right.
You know, typically the more concrete you have, the less thickness of protection is necessary on the underside. As a general rule, I'll say, looking at the various UL designs, minimum thickness of concrete is 2 1/2 inches of lightweight concrete, or 3 1/4 inch thickness of normal weight is a typical minimum thickness above the crest of the deck.
Sure.
But it's ultimately what falls out of the testing and falls out of the various listings.
Fair enough. And what Rich is referring to is structural lightweight concrete, not necessarily lightweight insulating concrete.
Correct. True. Yeah. The typical 105 or so pounds per cubic foot concrete is what I'm referring to. And there are some what's referred to as unprotected designs, where the bottom of the deck is typically not sprayed, and they have some applications, some usefulness, but there are some limitations as a result of not protecting the bottom of the deck also.
Fair enough. Okay, so let's see. The person is then saying, asking questions about generic thicknesses. And again, there are no generics, if you will, in fire resistance when it comes to SFRM fireproofing and IFRM fireproofing. There's a thickness of the deck stated. There might be unprotected deck. There might be protected deck with a certain thickness of fireproofing on it. Same thing with beams and columns. It's all listed in the listing. Let's see, next question that came in. When calculating the thickness of a beam or a column full flange, take the average of all the points, correct? If the flanges are lower than the design thickness, are we good if the average is over? Thoughts?
I think my earpods are dying. Yeah, no, I think my earpods are dying. Can you repeat that one more time?
Okay, when calculating the thickness of a beam or a column full flange, we take the average of all the points, correct? If the flanges are lower than the design thickness, are we good if the average is over? Throwing a lot of stuff at you, aren't they?
Yeah.
I could jump in if you want, Jason.
Please, Rich. Yeah, please.
Okay. Yeah. The requirements of ASTM 605 really specify taking the thicknesses at various points around the perimeter of the beam or perimeter of the column, and then no individual thicknesses shall be less than 1/4 inch less than what's specified if the thickness is greater than 1 inch. The nominal thickness is greater than 1 inch, or 25% less if the thickness is less than 1 inch. So if you have those flange tips that are more than 1/4 inch or 25% less than what's required, then that would not be acceptable, even if the average was acceptable. So there need to be some remedial action in that particular case. And that remedial action could be applying more material to flange tips, or I suppose if the overall average is sufficient to meet a half flange thickness design requirement, then that would be another answer. So you have to look at the individual numbers and try to make that determination based on the design that you're using. Did I meet the half flange thickness requirements? And if so, then you're good to go. And if not, then you'd have to put more protection on the flange tips.
Fair enough. Another person asked about attachments. We're not going to get into that for today's webinar. We are going to get into that for a future webinar, because there's a lot of research going on right now at NFCA and other places about what constitutes an attachment to a primary structural member, whether it's a beam or a column. You know, is a threaded rod holding up a cable tray? Is a ceiling grid wire that holds up the ceiling grid? Is that an attachment? Those are some of the questions that are going on in the industry now that we're going to answer at a later date in a later webinar. So stay tuned, be part of us. You know, keep an eye on the website for the next webinars, and then you know, always keep in touch with us. info@nfca-online.org. So I'm looking at the questions. I don't see anything further coming in. So questions going once, questions going twice, questions going 3 times. Not seeing anything there. Not seeing anything in the chat. I guess what I'll do now is say a big thank you to Jason Anastasi for spending some time with us, Rich Walke also for spending some time with us, most importantly you for spending time with us. If you're a member of the NFCA, thanks. We appreciate it. Your dues help pay for the talent that you see here. If you're not a member, I'd like to reach through the camera, grab your credit card, put it in, and charge you to be a member today. That'd be the easy way, but we'd love for you to email us for a membership application. Think about your membership as an investment in the industry. It's not just the let's go to a conference, let's do this, let's get listed on the website, but there's a lot that the NFCA does to advance the fireproofing industry and advance fire and life safety in buildings. Think about it as tuition for being a part of the industry, if you will. It's not mandatory. We don't demand people to join, but we sure would appreciate it if those on the call that are not members would join the association. So we'll wrap things up and say thank you again to Jason and to Rich. Really appreciate you taking some time. Thank you to the audience that paid attention and stayed with us through the questions. Look for an IFRM education webinar. Look for a board and wrap education webinar. We'll look forward to doing that together with our stars here on the line. So thanks again, everyone. Signing off from the National Fireproofing Contractors Association, Bill McHugh on behalf of Jason and Rich. Anything to say there, Rich? We're wrapping up. Rich and Jason. Rich first.
Other than I'll say thanks for joining us. Hopefully it was beneficial, and we'll see you next time.
Thank you very much.
Thanks, Jason. Thanks, Rich. Appreciate all you guys do. From Chicago, signing off. Thanks, everyone. Have a great week.